In this video, we're going to go through the Learning Target 323 and 333. And if you have a packet, it's on page 19. Otherwise, you can just use a notebook. If you're using a notebook, if you could go ahead and pause this video and draw this table, that would be great. You don't need a ton of space in these spots, but you have to have all of these pieces. So pause, draw this, and then come back. So for each of these, we are going to be graphing inequalities. So we graphed equations already, and we're going to be graphing inequalities, which follows a very similar process, but we just have a couple extra things we need to worry about because they're inequalities and not equations. So the first thing is that all of these are related to the symbols. And so instead of an equal sign, we're going to have a symbol of some sort. So less than looks like an L. And so less than or equal to is like the L but a line underneath. Greater than is the opposite, and then greater than or equal to. So now when we graphed equations, we just graphed a line. So we found 2 points and then we graphed the line in between those 2 points. We don't really have to worry about it. However, with inequalities, we have two types of lines. We have solid lines, which is normal, and then dashed lines. So the way that I remember this is that the or equal to pieces, the ones that have the line underneath, are going to be solid lines. Kind of like in Unit 1, we talked about if there was the or equal to part, we kind of saw that as like a crayon, so we color in the dot when we were graphing on a number line. It's the same thing. We're going to have a solid line if there's the line underneath. If we don't have the line underneath, we're going to have a dashed or dotted line. And so the first decision you make is whether you have a dashed or solid line. Then you're going to decide where to shade, because inequalities talk about an entire range. If it is greater than 2, for instance, that means every number greater than 2 would be a solution. So we have to shade an entire region of the graph. And so for shading, we are going to pick a point on one side, plug it in, and see if it's true. And we'll talk about that in a second, and then I want you to also put 0, 0 is the easiest. Because when you plug in zeros, everything kind of goes away, and so 0, 0 is definitely the easiest. Although if 0, 0 is not on one side or the other, if it's on the line, we can't use that one. So pause it if you don't have this, but if you do, let's go ahead and do a couple examples. So this first example is to graph this inequality. And again, yours is going to be a sketch if you do not have the packet, so just go ahead and sketch a coordinate plane, do 10 dashes on either side. You can go ahead and draw 2 because you're going to need them for both. After these two examples, all of them are multiple choice, so you won't need to draw anymore. So when we have this, we are going to either graph using the M and the B method from last unit, if it's in y equals mx plus b, or using the zeros method if it's not. And so for this one, I begin with b, which is -2, and I put a dot on -2 on the y-axis. And then I move with m, which is 3. I want to make that into a fraction so I can see my rise and my run. And so this is a review from last unit. Now we're going to start at our point, and we're going to rise up 3 since it's positive, and over to the right 1. So 1, 2, 3, to the right 1. Now you are going to use anything with a straight edge to draw your line, but we need to decide if it's going to be solid or dashed. And so what you look for is if we have the line underneath the inequality. Since this one does, this is going to be a solid line. So I can just go ahead, line it up, and draw my line like normal, all the way through the entire coordinate plane. If it was a dashed line, I will show you what that looks like for this example, but you just kind of make dashes instead of connecting it all the way. And now we need a shade. So if this is an inequality, you have to shade it. And we have to decide where we shade. So what you're going to do is you're going to pick a point either on this side or this side. If it's true, that's where we shade. If it's not true, then we shade the opposite side. So the easiest, like I said, the easiest point to use is 0, 0. If it's not on the line, you can use 0, 0. If it is on the line, you have to pick a different point. Like I would have to pick, 10, 10 would be a good one and an easy one. I like to do ones where x and y are the same value. So we're going to plug in 0 for x and 0 for y because that's the point that I'm choosing. So 0 is greater than or equal to 3 times 0 minus 2. Now, like I said, the nice thing about zeros is that will cancel, so I'm left with 0 is greater than or equal to negative 2. And I need to ask myself if this is true. Is 0 bigger than or equal to negative 2? 0 is bigger than all negative numbers, so that is true. So we do shade on the same side as 0, 0. So wherever, like toward where the x was. So you kind of just scribble through to shade that whole side. If it was not true, we would shade the opposite. Let's do another example. This one is not in slope-intercept form, so I have to use the zeros method to be able to graph it. So I'm going to plug 0 in for x and 0 in for y. Let's do x first. The 0 cancels. I divide by negative 2. And the inequality doesn't really matter for this because we're just trying to find the intercepts anyway, so you can even change this to an equal sign. Our y-intercept for this is negative 4. I'm going to plot that on the y-axis. Now I'm going to do the same thing but plug in 0 for y. My 0 part cancels, I divide by negative 1, and I get x is negative 8. So again, go to negative 8 on the x-axis and draw a line. And now before I connect my dots, I need to see is it going to be dashed or solid. Since this one does not have the line underneath, we want a dashed line. The only thing you do differently is you just connect in dashes and not a solid line. So I line it up the same, and then I just kind of lift my pen so often so I'm left with a dashed line. If you accidentally draw a solid line and then you're like, oh crap, that was supposed to be dashed, you can just leave a little note on your work, or you can type in your work or something that says that it's supposed to be solid. However, most of yours are going to be multiple choice, so you won't have to worry too much about that. So now let's figure out where to shade. So again, we're going to pick a point. 0, 0 is an option, so I want to use that one. Plug in 0 for both x and y. All this cancels, so I have 0 is greater than 8. And I ask myself, is 0 greater than 8? That is not true, so I do not shade on that side. I don't go toward that side. I have to shade down here. And so the basics that you have to decide is solid or dashed, and then shade above or shade below. And so those are the two things you need to know how to do because yours will be multiple choice. And so this one asks us what graph correctly shows this equation. And you can see the line is all the same. What's different is where it's shaded. So these two are shaded above, but one's solid and one's dashed, and these two are below. One solid, one dashed. So first thing I'm going to do is figure out if it's a dashed or solid line. I notice that this does not have the line underneath, so it's going to be a dashed line. So I can automatically get rid of A and C. Now I'm going to choose a point, and I'm going to choose 0, 0 to plug in to check to see where we shade. So if 0 is less than 2 times 0 plus 3. So this says 0 is less than 3. And we ask ourselves, is that true? That is true, so we need to shade toward this 0, 0 point. So B is not our answer. Our answer is D. And so when you're doing the multiple choice, that is going to be what you want to complete.